Okay, one of the key things when we do the Monte Carlo simulation, especially in option pricing problems, is going to be sampling from the normal distribution. And in MATLAB, it's not a very difficult task because we have some built-in functions like norm R&D function. So for example, if I type norm R&D, so it's going to generate a standard normal, well, in this case, it's going to generate a normal random variable with mean equal to 0 and variance equal to 1. So we can check this function. So you can see in the MATLAB's help file, if you click norm R&D function, you can see it has two inputs in the first form. So you can input the mean and the standard deviation. And additionally, if you like to generate more than a single normal random variable, you can also input the dimension of the vector or matrix of normal random variables that you want to generate. For example, you can say I want the mean equals to 0. Let's say the standard deviation equals to 2, and I want to generate, let's say, 10 by 2. Okay, so you can see it creates us this matrix of normal random variables with mean equals to 0 and standard deviation equals to 2. So here also there is some simple MATLAB example, and you can generate the normal vector n by 1 in this example, and actually we can also create a histogram to check whether our random numbers looks like coming from the normal distribution or not. So you can easily do that by creating this vector of normal random variables, norm R&D, and let's say the mean is let's say 0. Let's change the mean to 0.5 as an example, and let's say the standard deviation is 2, and let's create 1000 normal random variables, and let's make a plot of this using the histogram. And you can see the plot. Indeed, our 1000 normal random vector looks like coming from this theoretical red line. So basically we can match this red line with the histogram, because this red line is the theoretical normal density plot, and the closer this histogram is to this red line, basically that shows the MATLAB's random numbers are actually are looking okay in terms of replicating the normal random variable. So as you increase this sample size, of course, you can get something closer to this red line. And you can see that as we generate more and more normal random numbers, it looks closer and closer to the theoretical normal density function, which is as expected. So we will be using this normal random numbers, especially when we do the simulation of stock prices, because these stock prices are assumed to follow the geometric Brownian motion, and basically in order to generate the Brownian motion we will need to sample random numbers from the normal distribution.